unit 1, that is alpha beta pruning. Okay, so hope everybody are joining quickly. H not, are you there? Hemant is not there. Suhana, are you there, ma? Suhana, are you there? Both seers are not there today. Hmm? Why? What happened? Anybody from your section just put a message that class started. Join quickly. Okay. We'll wait for a couple more minutes and we'll see. Let the other join quickly. Yesterday's class you have understood or anything you want me to repeat? Anybody? Anybody in the section? So we'll have a 1 minute of 1 to 3 minutes of revision with the previous class. Then we'll go with alpha beta pruning and then I'll start second unit introduction part. Okay. Already 5, only 40 joined. Why? Why? What happened? Everybody should be present in the class. At any time, one of the faculty will come or a higher official or HOD sir will come and ask how many assignments you have done. Only 63 are in the class as part of a classroom people. And the remaining, I don't know why they are not joining, especially C9 and H5 and other people, those who haven't joined till right now. And 16 series, 5C9 also not joined. 19 series lateral entries are also not coming to the classes regularly. Yesterday also only 53 people joined. Why? It's already 7 minutes. You have 1 hour break, right? So you need to join quickly. Yeah, okay. Let it be. I am going to start the class right now. Let it be. So I'll take at the end of the class, I'll take attendance. And I'm going to F4 why you left the meeting. And I'm going to give today's attendance to your class in charge and HOD sir. Let HOD sir take action, okay? Most of the people are not joining. Leave it. Hope I'm audible to everybody. My screen is shared properly. Put a message in chat box, yes or no. Am I audible to everybody? Is my screen shared properly? Yes. Okay, fine. Hemant, send me today's attendance. We'll take attendance at the last 5 minutes, 5 to 10 minutes, okay? So today we are going to discuss on this. Okay, fine. Thank you, everybody. Okay, right. Thank you. Okay, fine. So yesterday we have discussed about these two strategies, only strategy. So we have discussed about all these things yesterday, right? So how to solve this script arithmetic problem, and with example call two words, so we'll get third word as a result. And we have seen all these things right yesterday. And we have seen this. There are some constraints to be followed when you are implementing such kind of a logic to be done as a as like a two words. When we do arithmetic operation, we'll get the result as a third word, right? Other examples which I mentioned yesterday. So we have discussed all these things yesterday. So today and gameplay also we have discussed, right? So how gameplay is important to artificial intelligence? What are the histories of gameplay, history of gaming in AI? most of the artificial intelligence are concentrated chess as a game playing. They have taken chess game as the one of the example in developing AI as a game playing, right? So we have discussed this one also, right? So two players game, each player and zero sum, very easy. These are all the theory related part. And one important point we discussed, right? So BFS cannot be applied to game playing, right? So BFS it follows method for search, like it follows DFS method, right? Depth first and the depth limits, right? So min-max algorithm we have seen yesterday. So what is the disadvantage of, we have seen two important terms, right? Move gen and static evaluation, right? So which generates all possible moves to reach to the what you call final destination. And we have taken one example as a tic-tac-toe, right? So I said that I'll give you a 1 minute video how we can do min-max algorithm, how we'll apply min-max algorithm to tic-tac-toe game playing, right? So min-max algorithm here using two functions, move gen and static evaluation. So we have seen this graph also, right? Sorry, this tree also, right? How depth levels have been defined and how many levels are there. If player one take maximum, player two has to take minimum. So how if it follows a depth first, how it will perform, we'll see. We are going to see in alpha beta prone. Why? Because it won't follow breadth first search. So it is a depth first, depth limited search. So depth first, depth limited search. These are the important constraints which I want to tell you for a 1 minute, right? Min-max algorithm is a two-player game, right? So there will be a two players, player one and player two. If player two starts, it will be a maximum. If player one starts, it might be a minimum. Here, player one is backed up the value. Player one has started, so it will be player one will be considered as a maximum value, minimum value. So that's why we'll get as a min-max algorithm, right? So player two, the backed up value is the minimum value. Player one is the maximum value. All right. So this is the example which I have taken yesterday for min-max algorithm. So a real-time example of min-max algorithm is using tic-tac-toe game. So I'll show you how it been developed with Python programming. Yesterday I said you, right. We'll see at the end of the this small topic for 1 minute, right? So it provides most promising move to player one, assuming that the player two has made the best move. If both players play intelligently, then it's going to be a tie, or else one player will win or one player will lose. That is what I have said here. Sorry, I want, yeah, this one. Yeah, this one. Each player has a global view of the board. Zero sum game. Any gain for one player is a loss for other. One player wins means other player it's a loss. So any gain. Suppose if unfortunately system or any thing might do a small mistake, so it will be an advantage to the other user here. So that is the one important point I want to tell to you. I want to discuss with you. So yesterday we talked about and we discussed in this session about min-max algorithm, and this is what there are four levels. How it considered as four level also I have said, right? So from A to from the bottom O child node, so there will be a four levels here, right? So here how it will be considered as a four levels. Here it is level one, level two, level three, and level four. So it will be considered as total four levels here. Okay. So when coming to the next slide, so here it is saying, we assume that player one will start the game. Four levels are generated. Here, suppose we might maximum might consider here itself only. So player one starts, then player two, then player one, then player two. So this is how it will be considered, one after the other. So here, if it is player one, player two, again player one, again player two. So here player 2 means minimum value, player 1 means again maximum value, player 2 means again minimum value, player 1 means again maximum value. You need to remind such kind of constraints, right? So when you go on develop such kind of min-max algorithm. So this is one which I want to discuss with you. Level 3 is maximum level. So all nodes of level 3, here level 3 is considered as first, suppose here from level 1 it has started maximum value, so player 1 started, so 12 23, which one is maximum? 23. So player 1 takes 23 here. So like this it goes on till the last level. Okay, so level 2 again minimum value, right? So here from the child nodes of B and C, so there are two nodes from A. So one is B and C. So B has two child nodes, C has two child nodes. It takes the minimum and maximum value from the child nodes. A has two child nodes, B and C. So it is taking the minimum or maximum value from its child nodes only. Okay, remember that point. Okay, it will take from its child nodes. Okay, so here B and C will take from its child nodes. So here minimum, why? Because here player 2, why? Because player 1 started first. So player 1 means maximum value, player 2 means minimum value. So this is how backing of values will come into the picture from bottom to up. Okay, so from here again maximum value. So here already values are defined from there, might assuming that there might be some below what you call child nodes or nodes, parent nodes. Okay, this is how we discussed yesterday. And one more thing here, why this is considered as this path. I'll give you assignment to you for this one. Anyway, we'll discuss after some time. Okay. So I have already posted this PPT in your group. Anyone in the class who can tell why this min-max algorithm for tic-tac-toe has taken only considered this one, then I will give 3 marks to them. So they need to explain why this one is only considered, even though we have wins here, even though we have wins here and other these wins, why they are not considered, these wins they have considered, you need to tell. Okay, this is assignment for you, anybody. So I have posted already this PPT in your classwork. So you need to understand the concept and then come up with the solution. Okay, this is how tic-tac is implemented with the Python program. Okay, I'm sharing screen with you. See here, Yeah, 1 minute. Suhana, is it audible now? And is the video audible right now? I'm playing here right now, you see.
Yes, sir. It's stuck in.
Audible, right? So most of the people are
Audible, sir.
telling it's not audible. That's why I
Now
called.
it's audible, sir.
Okay, okay,
It's
fine.
breaking in the middle, sir. Back then it was breaking.
Earlier it was okay or it's not good?
Yes, for some time it was stopped, sir. Now it's okay.
Okay, fine. Now you can listen here. Yeah. Just now we have seen, right? So this is how programming will be done for your Python, right? So for tic-tac-toe. So see, I shared here what you call link to if you want to go in-depth analysis of how min-max algorithm is applied to tic-tac-toe. Okay. So you can go through that link. You can see, you can go with description is saying that if you want still more explanation related to tic tac toe, how to code that one, so you can go with description. Okay. So this is how min max algorithm. First, have you observed or not? So it is taking the left path actually. Why? Because it follows DFS, then it will backtrack again, then it comes to B again, then it will go to E, then J, then K, like this. So first it comes A to B, B to D, D to H, then backtracks, then high, then again it backtracks, then go to B, then E, J, K, like that. So it's a depth, so it is a depth first, depth limited search. Okay. So game playing, for game playing we can't apply BFS. Okay. Fine. So this is about min-max algorithm. So the major disadvantage of min-max algorithm is, suppose if we are not going to, uh, suppose if we trace all the nodes over here in the tree, suppose if there is no goal node at a way which we are going, so it's a waste of tracing all the remaining nodes. So we require some pruning over here. No need to check again and again. So if at all it is not leading to the destination, so that's why we go with alpha beta pruning. Okay, the next topic and final topic of your what you call first unit is alpha beta pruning. Okay, so this is similar to your min-max algorithm, modified version of your min-max algorithm. So what is the disadvantage in min-max algorithm is, so it applies it, so it follows depth first search. So what's the reason is, so it goes on what you call tracing out all the nodes. So even though if it can't lead to the destination, so that is one major problem with min-max algorithm. So it takes a lot of time to trace out and to traverse all the nodes from left, again backtrack and again go to the next child nodes of each and every node. So it is a time consuming, right? So we know that suppose if it go in that way, if that path also, if it not leads to the destination, it's waste of time. It is roaming all around, and if you not reach to the destination, it's a waste of time. So a min-max algorithm takes more time, even though it doesn't reach to the destination at some paths. So that's why we go with alpha beta pruning. Okay, so pruning in here in the sense is eliminating the unwanted nodes which are not leading to the destination. Means deleting, we call it as. So in data mining also there is a concept called a tree pruning. So you're going to learn in decision tree induction. So there is a concept of tree pruning. So why? Because we'll get some duplicate nodes so that we can able to prune the tree and make the tree into a useful one. So here also in alpha beta pruning, it's a modified version of your min-max algorithm. So where we are applying optimization technique to your min-max algorithm. So as I said that, so here you can observe in third point of this one, as we have seen in the min-max search algorithm, that the number of game states it has to examine are exponential in depth of the tree. Since we cannot eliminate the exponent, but we can cut it to off. Why? Because if you go on depth of the tree, why we'll get more exponential part. So we can eliminate, we can cut it to off. Yeah, we can sometimes we can't eliminate, but we can cut it to off. Hence, there is a technique by which, without checking those technique, that technique is called as a pruning technique. Why? Because so we can eliminate the unwanted leaves or subtree, entire subtree. So we are going to see with an example of that one how we can eliminate the leaves and entire subtree of a what you call alpha beta pruning. This involves two thresholds here. So here pruning in the sense what, eliminating the unwanted and what you call useless node. Even though we trace out the path, we can't reach to the destination. So it's a waste of tracing that paths and finding out the minimum and maximum value. It's a time consuming, right? So we eliminate that what you call subtrees or leaves or anything like that. Okay, this involves two threshold parameters. Here I am mentioning the word threshold. That means some value, some what you call interval value or some fixed value here. So those two parameters are called as alpha and beta. So it is called as alpha beta pruning. Okay, so it is similar to min max, but what's the disadvantage in min max is, if we go on tracing each and every node at every depth level, so even though it's not reaching to the destination, suppose from A to G you want to reach, but it is not leading to the destination G. So it's waste of tracing all the path. Suppose you are going from, suppose you are what you call coming from one source to destination. So you have got 4 to 5 paths. So one path which is not at all leading to your destination. So it's better you eliminate that path and take other paths which leads to the destination. That is the major intention over here. Okay, so that is where we are going to concentrate in alpha beta pruning. So alpha beta pruning can be applied at any depth of a tree, and sometimes it is not only prune. Just now I said it's not only prune the tree levels, it prune entire subtree. So that we are going to see also, okay, in the upcoming example. So the two parameters, just now I said alpha and beta. Alpha t is just nothing but your maximum value, beta is just nothing but your minimum value. There we are having min max, right? So player 1 will take maximum, player 2 will take minimum. Here we are going to have two parameters, alpha and beta. The best highest value, the best highest value choice we have found so far at any point along the path of maximizer. So here alpha takes maximum value, will what you call name it as minus infinity, and the beta value will be considered as, will take the lowest value, will consider it as plus infinity value. So we have got two symbols here, infinity symbols, and we have mentioned it as minus and plus. So alpha takes minus infinity, beta takes plus infinity. Remember this one, very important. Okay, so two parameters we are going to consider. There we have considered maximizer and minimizer. Here we are considering alpha and beta, that is the only one. Okay, and the alpha beta pruning to standard maxim min max algorithm returns the same move as the standard algorithm does, but it removes, it is similar to your min max algorithm only, but here it is concentrating on pruning concept, that is removing of nodes which are not really affecting the final decision but making algorithm slow. So there the algorithm might works very slow. Here if you prune, if you prune the leaves and the subtree, then you will get what you call quick results or quick decision making, right? So instead of tracing out all the nodes and reaching to final destination is not possible, means it's a waste of time, right? So that is the major thing the alpha beta pruning is going to concentrate. Okay, so it makes the algorithm faster. The disadvantage of min max algorithm is tracing out all the paths even though sometime it's not reaching to the destination. Okay, so this is where we need to concentrate. The major condition to satisfy alpha beta pruning is alpha greater than or equal to beta. This is one important point where I want to mention. So with respect to artificial intelligence, so alpha should be greater than or equal to beta. If this condition satisfy, if the other even though if we trace other path, it's not reaching to the destination, means so we can prune here itself. So we no need to trace out this path if this condition is satisfied. Remember this one, we are going to look into this one in the upcoming example. Okay, yeah. And the key points to be remember, the maximum player will only update the value of alpha. Alpha means maximum value. The minimum player will only update the value of, sorry, beta. Yeah, beta means minimum only. While backtracking the tree, what is backtracking? What is the concept of DFS? It takes the left node tracing and again come back to the previous. This is what we call backtracking the tree. The node values will be passed to upper nodes. Just now we have seen here, right? Yeah, this one you can observe. So here, if you take uh, depth first and depth limited concept to alpha beta pruning, it comes from A to B, then B to D, then again it backtracks to B, again it goes to E, again it backtracks to B, it will go here, again it will take this path, and again it goes to F, again backtracks, right? Again it will go to here, again it backtracks, and again it comes here. This is how it goes on. Shall I repeat again? how it goes on actually when we apply DFS to this kind of backtracking, sorry, this kind of alpha beta pruning graph from A to B. DFS will follow left, it starts from left tracing nodes, A to B child node. There are two child nodes for B, D and E. Then from B to D and D to B again, and from B to E again, and backtracks to B, then update the value of maximizer, again go to A to C. Here C is minimizer, so it will update the C minimizer. Then it will go to again F, it will here update the maximum value, then again backtracks, then again comes to G, again backtracks, again goes. So this is how DFS is working for such kind of examples, right? We'll see here. But this is what I have shown you, that is for min max. Here, what the concept is, even though we won't reach to final destination, or if it satisfies this condition called alpha greater than or equal to beta, then no need to trace the right, then no need to trace any of the left or right child nodes when this condition satisfies. Which condition? This is the condition alpha greater than or equal to beta. So this is a major concept in alpha beta pruning. So the what is the major point we need to remember is, we need to prune based on this condition only. We need to prune. Prune means delete, elimination of the sub leaves, sub leaves or entire subtree. Here, while backtracking the tree, the node values will be passed to upper nodes instead of values of alpha and beta. We'll only pass the alpha beta values to the child nodes. So remember this point, very important. Okay. So next slide. So let's take an example of two-player search tree. So in with respect to your exam point of view, so already they are going to give some tree like a structure, and then they will ask you to apply alpha beta pruning and find out the value of A, like that they will ask. Here we need to find out what from all the bottom values, what the A will, what is the root node, whether it is maximum. So obviously it is maximum. What value? Which maximum value? What is the actual value of this A root node? That is the major intention of this alpha beta pruning. At the first step, the max player will start first move from node A, where alpha equal to, yeah, we have already seen alpha equal to minus infinity and beta equal to plus infinity. These values of alpha and beta pass down to node B. Here it is node B. So here initially the player starts from here. That is who the maximizer. Who is the maximizer? Alpha is the maximizer. Alpha will start here first. Node B passes the same values to child node to D. So from B to D, that is intention. And beta passed down to node B. Here beta will be passed. The top node is alpha, right? Again here alpha comes here. Node B passed to same values to its child node D. So similarly it comes like this. Okay. So why? Because min max algorithm and alpha beta pruning will follow depth first, depth limited search. Okay. So moving to the next step. Hope you understood this point, everybody. At the first step, the max player will start. Here the max player will start. Okay. First move from node A, where alpha equal to minus infinity, beta equal to infinity plus infinity. These values of alpha and beta pass it down to. These values will be passed to B, then from there to B, so and so on, backtracks and again comes back. We'll see in step 2. So here in step 2, you can carefully, at node D, you can observe this one. At node D, the value of alpha will be calculated as its turn for max. As it's done for max. Why? Because here max, min, again max here. So it will update the maximum value, right? So here alpha equal to 3 and beta, here only the value, maximum value will only be updated, not the minimum value. Okay, not the minimum value, right? Why? Because here maximize, there are 1, 2, 3 levels only here. Earlier we are having some 4 levels also. So this is the third level, second level and first level. Okay, depth levels of this alpha beta pruning. So at node D, the value of alpha will be calculated as its turn for max, the value of alpha is compared. So what is the here node D, you are going to have two child node values 2 and 3. So here when comes to D, only the maximizer will be updated. That means your alpha will be updated. So alpha equal to 3 here. Okay, fine. Now algorithm backtracks to node B. If you go to step 3, now algorithm backtracks to node B, right? So here node B means what? Beta will be updated. Why? Because here the minimizer will be there. Okay, so but here we don't know the E value, so which we are going to look here right now. Before that, we'll trace out this what you call E node, then we'll finalize this one, which value the B node is going to take. Okay, obviously by observing here we can see 5 and 9 are there, so obviously 3 will be considered. So here change as the turn minimum. Now here the condition is like this here at the B node. Hence at node B, now alpha equal to minus infinity, only beta value will be updated. Why? Because at D alpha is updated, now here beta is updated. If we observe carefully to these slides and understand min max algorithm, this is very easy actually. Moving to the next slide. So at where we are here, from here we need to trace out E. So E has two values here. So here 5 and 9. So here you can observe here, no need to consider this, no need to trace. Why it is mentioned it as wrong? Because 5 is satisfying, this path is satisfying this one. Which condition? Alpha greater than or equal to beta. Which one is alpha here? This one is alpha. So this point is very, very important. Why? Because it satisfies alpha greater than or equal to beta. Hope you understood my point. Okay, why? Because we traced child nodes of D, right? So while tracing out each child nodes, at the first child node left side, why? Because DFS followed depth first, depth limited search left side. While tracing this child node, we got 5. That means we need to check condition whether alpha here maximizer, right? Alpha is greater than or equal to beta.
Srinivas sir,
Madam.
please stop for a while.
Okay, madam.
So you go back to previous slide, sir.
Okay, madam.
A C7, C7. Hey, Abhishek, unmute yourself.
Yes, ma'am.
Just explain how for node D, how you got alpha as 3 and beta as infinity. Hmm? Just explain for node D. What happened? This next H2, roll number H2. H3, H6. Yeah, H2 is present. What I am asking, just explain how you got values for node D, alpha and beta values. Sir, put absent to all these students, sir. They are not
Okay,
following the
madam.
class. Can
Every
anyone,
time I'm asking,
Vishnuti,
madam.
Nimisha, any other? Why no one is responding, ma? What happened? At least in chat box. Sir, for everyone you put absent, sir.
Okay, ma'am. Why none of them are responding? Hmm? Why none of them are responding, ma? I don't know. If you're not following, or just at least you can stop for a while. Then we can go with each slide for a minute and we can discuss now. Just simply keeping yourself mute and you are not at all. See, leaving 19, 5, 16. Today all are absent. It's fine, right now? H2 is not at all responding. Through chat box every time. What happened to CR? Why you are not responding through your what you call mic or headphones? What when madam asked anybody in the class why you are not responding? Hmm? Now you are happy, right? Entire section has got absent right now. Why you are not at all responding? I don't know. That means you are not following class properly. Leave it's your wish. You are paying money, and you are not at all listening to class. It's okay. Nothing happens over here. If you're not understanding, yesterday I asked, few people said that why it has, sir, why it is like that, why the value is there like that. So one or two students at least they asked, at least few people, you need to answer, right, what we are discussing in the class. So leave it's your wish, I can't do anything. When madam came and asked, can you explain why D is at D node, why alpha equal to 3 and beta equal to infinity? Here I said maximizer will only update the maximizer value. That means alpha will only update. At B, here minimizer is there, only beta will be updated. So you can't give such simple answer. You're getting this one. These key points I mentioned here in this slide, the maximizer, the max player will only update the value of alpha, the minimum player will only update the value of beta. Simple, right? What is there in that much big task over here? I don't know. Simple. Every step we are mentioning over here. Can't you understand? Now it's good, right? It's not only what you call it's a question to me also, that you people are just keeping your what you call mobile phones in mute mode and you are not at all listening simply, right? It's your wish. Go to hell. Who will care about you? Coming to college, we are making you to learn like anything. We are facing so many difficulties also. Leave it. It's your wish. Who is bothered about? What is the maximum will happen here? Huh? You are only losing. Simple thing you can't understand here. You came to third year and you are asking simple. You are coming up with a simple thing like blaming the faculty or others. Simple. That is, even I can also blame faculty. Can't you understand these simple words which have been placing over at the slides? Simple words, right? At node A, max will take its turn. At node D, see here, at node D, the value of alpha will be calculated as its turn for max. Here it is mentioned in step also. Still you are not telling if anybody comes and asks you. Here simple it is, see, two values are there at D, 2, 3. Then what is the max? 3. Then alpha is updated. Why? Because alpha is maximum, beta is minimizer. So beta will be updated at node B. Even none of the entire class, nobody is answering at least If ma'am says that anybody in the class, so you're all unfit to be in third year, huh? Tell me that's it. If you're not understanding, stop for a while and ask questions. I said, I'm only saying now, interrupt the class, ask questions, ask questions. Okay, fine. Today you are all are absent. What is the use of this one? Discussing entire thing, waste of this thing. I won't repeat it at any cost. From all these days, all other sections are been completed. Even my subjects also, colleagues also started second unit of me. Still, I'm discussing simple things over here, and you are just keeping yourself mute like a dumb fellows. Leave it. What will happen? Nothing. I'll go on my way. Those who are listening, let them listen. So coming to step 4 at node E, so we traced out this path and we got something like here minimum value is updated here, right? At D, alpha is updated. At B, so now we got one value over here, so beta is updated. So we didn't trace out E route. So when we trace out E, it will go to E child node and update the value of 5 and checks over this condition whether alpha is greater than or equal to beta, whether alpha is greater than or equal to beta at B node. Here the condition satisfies. At B node, it will checks here whether here why, because this is a maximizer, so alpha will be there. Here beta will be there. So earlier we don't have beta value over here in the previous slide. This slide. So now it is updated. Now it checks condition after tracing each child node. So here I got 5 value. Now it's checking whether 5 is greater than or beta is updated over here. Sorry, alpha is updated over here and I got already beta value. Now it is checking condition alpha is greater than or equal to beta. Yes, it is. So no need to trace out the child node of another child node of E. That means we can prune this one. This is the better example of pruning. No need to go this path and check the value which I am talking you right now. If you look at into the slides once or twice, then it will be very easy to understand. Still you are unable to answer simple question. So the only conditions we are going to check here is this is the main condition which is required for alpha greater than or equal to beta. Why? Because we are what you call discussing about alpha beta pruning, right? Min-max concentrates each and every node and it takes time and checking of each and every value at the each and every child node of what you call parent node. So here D has 2 child nodes. If we consider min-max, it will trace this one also. It will trace this one also, but here not required. Why? Because the condition is satisfied at E child node. Alpha is greater than or equal to beta. No need to trace out this. Why? Because we need to get optimization. We need to get optimization. Similarly, moving into the next slide. Moving into the next slide also, step 5. At the next step, algorithm again backtracks the tree from node B to node A and updates its value. How it is updating? So here I got 3 here in the previous slide. So again it will backtrack here. Again it will backtrack here and updates alpha value. Why? Because here maximizer is there. So it will update to 3 alpha. So beta we didn't trace. So after tracing out, it will update beta value here. Then it will finalize max of alpha and beta. Then find out maximum value. Okay, that is our intention. Step 5, step 5 again backtracks and update alpha value. So now only thing is we need to find out beta value. These two values now passes to right successor of A, which is node C.